Okay, so if you recall the addition of water to an alkene, uh, and in this process sometimes the carbocation can rearrange. Okay, but we will see how we can stop that by forming a epoxide. Now if you recall, this is the mechanism of addition of water to an alkene and how the carbocation is going to rearrange, and this is your alkene. Okay, you have alkene, and then in the presence of sulfuric acid you are adding a hydrogen onto the terminal carbon, okay, from sulfuric acid. So you have sulfuric acid, so the carbon-carbon double bond goes and grab a hydrogen from sulfuric acid. So the less substituted or the more hydrogen carrying carbon will end up having a hydrogen. So you can see the terminal carbon would carry 3 hydrogens, CH3, and then the second carbon will carry 1 hydrogen and it will become positively charged. Okay, so and once this happens, it can undergo a 1,2 hydride shift because this is a secondary carbocation in order to make a tertiary carbocation. So the hydrogen shift can take place, 1,2 hydrogen shift. So the secondary carbocation will become now tertiary carbocation, and when you add water, so the OH, so we are going to add a water molecule across the double bond. First the water will go to the carbocation and then it would end up having, so if this is your lone pair on oxygen, so water molecule, oxygen of the water molecule go and attack the carbocation. So then you will see a water molecule, oxygen with 2 hydrogen will end up on the carbocation, and then the additional hydrogen can be lost and we can have our alcohol made. And this is addition of a water molecule across an alkene. And you could see that the carbocation rearrangement did occur. Okay, and we can achieve alcohol similar to that through epoxide, but without carbocation rearrangement. What do we need to do? So you take your alkene and first we can make an epoxide. How do we make an epoxide? In the presence of the alkene, you add a peroxy acid. MCPBA is a peroxy acid. Okay, parabenzoic acid, a peroxy acid. When you add peroxy acid, alkene will become an epoxide. And then you add another base, sodium hydride, H minus. So this is what happens. So this is the mechanism for this step. Sodium hydride, sodium is plus, H hydrogen would be the hydride. So this acts as a base, and since it's a strong base and this is going to take SN2 mechanism, so the hydride is going to attack the less hindered carbon. It attacks this carbon and the carbon-oxygen bond opens up. So will become O minus, and then the hydrogen goes to terminal carbon. Right? So in this process, oxygen ended up on second carbon. So there is no way that it can undergo 1,2 hydride shift and carbocation rearrangement because oxygen is now already attached to the carbon. So this is that step, and then when you add the hydrochloric acid, oxygen take a hydrogen from the acid and become alcohol. So the previous one is alkene. Hydration under acidic medium can undergo carbocation rearrangement, but in the second one, if you do the same reaction with an epoxide, we can achieve what we want without carbocation rearrangement. The regioselectivity is the same as acid catalyzed addition of water because the hydride ion adds to the sp2 carbon bonded to the most hydrogens, forming a trans 1,2 diol. So if you have a epoxide, you can make a trans 1,2 diol. So this is cyclohexene oxide in the presence of a base hydroxide. OH minus goes and attack one of the sides of the epoxide, and then the ring will open up. When the ring opens up, it opens up as a trans fashion. So you have your OH minus. So this goes and attack one side, and then the carbon oxygen bond opens up. So hydroxide going to come from one side and the oxygen will open up in the other side. So you will see a trans form. Okay, and then when you add, and you can actually have a mixture because it's not only this side, it can also attack from the other side. So you will have a mixture, but both of them are going to be trans diol. And when you add hydrochloric acid, you pick up the hydrogen and then become trans 1,2 diols. Okay. And if you want to form a cis 1,2 diol, you're going to be using osmium tetroxide in the presence of hydrogen peroxide and water. So cyclohexene, osmium tetroxide, hydrogen peroxide and water will give us cis 1,2 cyclohexane diol. And this is the mechanism for that. So this is the shape of the osmium tetroxide molecule, and it is everything happens at the same time, concerted mechanism. It's going to form a cyclic osmate intermediate. Okay, and then when in the presence of the hydrogen peroxide, this part breaks down, and then a water molecule will end up on the two oxygens, completing the diol formation. And this is a cis 1,2 diol. And now we're going to talk about amines. Amines cannot undergo substitution and elimination reactions. So here's the pKa of protonated alcohol, negative 2.4, whereas protonated amine pKa is about 11.2. pKa tells us about the acidity and the basicity of compounds. Protonating an amine does not form a compound with a good or weakly basic leaving group. Okay. Amines are common organic bases, and we can see the pKa's of some of the protonated amines. Amines are also common nucleophiles because they have a lone pair on the nitrogen that can act as a nucleophile. So this is ethyl bromide in the presence of methylamine. It's going to undergo a SN2 reaction. Okay. So how the SN2 reaction take place? So the nitrogen, lone pair of the nitrogen. So this is the lone pair on the nitrogen. It's going to go and attack a primary carbon, and then the bond between carbon and bromine breaks. So bromine leaves. So you can see ethyl methylamine is going to be the product plus Br minus. Okay. Same thing here. If it is SN2 reaction, lone pair of the nitrogen goes and attack the less hindered carbon. Carbon-oxygen bond opens up, and then we can form methyl derivative of the amine. And then the O minus will grab a proton. In fact, it can grab the proton from this protonated nitrogen. So there are two hydrogens over here. So the oxygen can grab one of these hydrogens and complete the formation of product. Okay, so they are common nucleophiles. Quaternary ammonium ions, they undergo Hofmann elimination reaction. So let's look at what is the Hofmann elimination reaction. So this is a quaternary ammonium ion in the presence of a base hydroxide. When you heat it up, you can generate an alkene. So this part over here is going to fall off or break away from the molecule. Okay, and then it will end up having a trimethylamine. A quaternary ammonium ion can undergo an elimination reaction with a strong base such as hydroxide ion, and we will see how the mechanism takes place in this process. You see here this nitrogen has 3 methyl groups, and also it has another alkyl group where the beta carbon has a hydrogen attached to it. So once the base is introduced, base goes and grab hydrogen from the beta carbon, and then the hydrogen carbon bond breaks, gives its electrons to form a double bond between these two carbons, and then the nitrogen and the carbon bond breaks, and then you have a stable molecule trimethylamine, and also you form alkene. In order for this process to take place, you can see that nitrogen has to have a side chain that has at least 2 carbons or more longer. If you don't have 2 carbons or longer, this process cannot take place. Okay. The base removes the hydrogen from the beta carbon bonded to the most hydrogens. So like I explained earlier, so this nitrogen has 3 methyl groups, and this is the beta carbon. Now in this case it shows you if you have 2 beta carbons. So this nitrogen and this is carbon, and this carbon has another carbon, and this carbon also has another carbon. So meaning there are 2 beta carbons. This is one beta carbon, this is another one. So then we need to know which one is the one that the base is going to remove the hydrogen. So the base removes the hydrogen from the beta carbon bonded to the most hydrogens. So which one has more hydrogens? This is 3 and this is 2. So the base will remove hydrogen from this one. And as a result, this is going to be the major product. And this is going to be the minor product. Okay. And this is going to be the amine that's going to generate upon the formation of the alkene.